खुद को खोकर ही खुद को पाएगा, रुकना काम नहीं तेरा, आगे बढ़ता जाएगा। मुश्किलें जितनी आए हिम्मत नहीं हारेगा तू, याद रख तू कौन है, पर्वत को चीर फाड़ेगा तू। पंख नहीं दिखते तेरे पर भर ले तू ऐसी उड़ान, उड़ जा नन्हे पंछी कर दे सब परिंदों को तू हैरान। कोशिशों से मिलती कामयाबी, कामयाबी का तू हकदार है। रास्तों की खाके ठोकरें, जीतने के लिए तू अब तैयार है। ओ रुकना कैसा, डरना कैसा, बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की।
Hello and good evening, everyone. I am your host Manpreet. Welcome to the fourth season of IST Practicals by Internshala Trainings. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience the power of practical learning. Today's session is about 3D printing, and our teacher today is Mr. Manas Seth. Manas is a mechanical engineering graduate with 4+ years of experience in digital manufacturing, rapid prototyping, and CAD. He is passionate about making new things that are tangible and not entirely restricted to the virtual world. He has been working as a freelancer in the field of design and prototyping for the past 2 years and has completed numerous projects in additive manufacturing. He has worked on projects related to the automotive industry, R&D and prototyping, architecture and construction, reverse engineering and replication to create working models for teaching purposes. I hope you will enjoy this webinar with him. We have a very special gift for you at the end, so stay tuned for that. And let's start our session with Manas.
Thank you, Manpreet, for such a lovely intro. And hello, everyone. And we shall straight get to the webinar from design to prototype with 3D printing. So I welcome all of you, and let's start this session with a small question round. So I would like to ask all of you, what is printing exactly? You may give your answers in the chat box, and whatever you know, you can just give a small answer to that. What is exactly printing according to you? Very good, Devhans Gotekar, if I have pronounced it correctly. Creating replica of your original copy. Yes, representation of a digital item in a real life form. Very good. Okay, so I shall give you the answer. The answer is printing is a process for mass reproducing text and images using a master form or a template. So, well, your answer was near to correct. See, what is printing? Printing is a process for mass reproducing text and images using a master form or a template. Now, if the screen present in front of you and I just press Control P, it will get printed. So the screen that is present in front of you is the master form or a template, and the printed copy that you get is a print, right? So, next question from me to you all is it possible to print something in the third dimension? Well, yes, that is correct. Many of you know the answer, and that is what about the webinar is. Yes, it is possible to print something in the third dimension, and that is what is called 3D printing, right? So, let me explain a bit about 3D printing to you guys. Now, in front of you on the screen, you guys can see a straight line, right? This straight line has a length of 100. Let's say we are not specifying the not specify the units, but let's say the length is 100. Now, what is the dimension of this length, right? It is not 2D, it is just 1D because it only has one dimension. It just has a length. Its thickness is negligible, maybe 1 mm or lesser than 1 mm. Its thickness is negligible, so it has only one dimension. But if I say to you how to make, if I tell you that if I place hundreds of lines one on top of the other, then what will it become? So once I place hundreds of lines one on top of the other, let's say I put 50 lines. So once I put 50 lines one on top of the other, this becomes a rectangle. What is a rectangle? It is a two-dimensional figure. The length is 100 as it was for the line, but since I place 50 lines one on top of the other, it becomes the second dimension. So the width is 50, or you can say the height is 50 or the width is 50, because there are only two dimensions. Now let's take this rectangle and change its view. We've changed the view of this rectangle. So still the length is 100 and the width is 50. But if we place hundreds of these rectangles one on top of the other, what will it become? So this is a rectangle, as you can see, and now I'm placing around 30 rectangles one on top of the other in the same figure. So what it becomes? It becomes a cuboid. And what is this? This is a third dimension figure, right? So once you get this third dimension figure, you know what is happening. What is a dimension? The first dimension is the length, the second is the breadth, and the third is the height, the 30. So 100, 50, and 30. These are the dimensions of this cuboid. So this is a three-dimension figure. But how to get it printed? Now, if you can just relate to what I'm saying, you print a specific set of figure on an A4 sheet and you print its variation on hundreds of sheets. Now, when you cut that sheet and place it one on top of the other, it will become a third dimension figure and it will become a 3D print. So that is what we are going and what we will learn today. So what are we going to learn today? We are going to learn about an introduction to additive manufacturing, 3D printing and its applications, scope and career in this domain. Now, many of you will think that it is restricted to just one type of engineering students, but it is not. It is this field of additive manufacturing or 3D printing is available to all the industries. It is being explored by all the industries in this in the current scenario. Currently, what the upgrade and all the due to all this artificial intelligence and everything, everybody is using 3D printing, and specifically a process of FDM. Now, FDM is a type of 3D printing, and we are going to learn about its process. So I shall begin with this. What is manufacturing? Another quick question for you. What is manufacturing? Well, manufacturing is the process of making some articles using machinery or any production technique. Manufacturing is the process of making an article, something that you can hold in your hand. That is the part, that is what manufacturing is, while using some machinery or any type of production technique, right? This is what is manufacturing. Now, what are the types of manufacturing? There are basically three types of manufacturing: additive, subtractive, and formative. Now, let's come to additive manufacturing. Additive manufacturing, as it is defined as the process of adding and joining materials layer upon layer to make 3D objects. Example, FDM, stereolithography, that was the first ever invented additive manufacturing technique, and there are many more, etc. Now, additive, I guess you all would really be connecting to it as to what I explained to you earlier in the dimensional process. So, additive is defined as the process of adding and joining materials layer upon layer to make 3D objects, right? Coming to subtractive manufacturing. Subtractive manufacturing is a process by which 3D objects are constructed by successively cutting material away from a solid block of material. Example, laser cutting, milling, etc. Now, let me give you an example of subtractive manufacturing, a very common example that in your childhood you might have used. Everyone used to do craft, right? You used to take some paper, you used to cut it in some certain shapes, and then you used to make something out of it. Now, when you used to cut the paper, the residue was the waste, and the main part that you got was the product. Now, that is what is subtractive manufacturing is that when you take a material, you remove the unnecessary part of that material in a certain shape or a design, and then the remaining part is the final product that you require. So that is what is called subtractive manufacturing. Now, coming to formative manufacturing, it is a use of suitable compression stresses like compression, tension, shear, which cause plastic deformation of the materials to produce required shapes during forming processes. No material is removed. Example, forming and casting. So, what is formative manufacturing? If I explain it to you in some with a very simple example, everyone might have used in their childhood clay. So, what is clay? Clay is a type of material, but when you made some things out of clay, you never removed a part of clay. You always formed it into different shapes. So that is what is formative manufacturing, is when you take a material, you form it into different shapes. That is what is called formative manufacturing. You remove some excess material that is there, but basically that is what is formative manufacturing. So here is a quick image representation of subtractive and additive manufacturing. So from the picture A, you can see a block of material that goes into the machine. Now that machine is the subtractive manufacturing. Manufacturing is happening over here, right? So material is being removed from this extra material, and waste material is being removed from this material, and the material left is what is called the 3D object, or the object that we desire, right? So this is what is called subtractive manufacturing. Now in the B part, in the downward flow of lane, you see there is material. That material is put into the machine, and then that machine processes that material, additive manufacturing that is, and then we get a product. we get the final product, but here the waste is very less because we are not removing anything. We are just putting material wherever we require, and we are getting the product directly. We are having some amount of waste material in there, but that is very less as compared to subtractive manufacturing. So a quick poll question: which manufacturing method is cost effective? Come on, guys. Let's say, which one do you think is cost effective? Okay, so I see a lot of answers over here, and most of you are saying additive, and that is the correct answer, guys. Manufacturing method which is very cost effective is additive manufacturing. And why is that? It is a very simple answer: because the amount of waste that is there in subtractive manufacturing is very high as compared to additive, and that is why additive is very cost effective. So a quick quiz over here. I will go to the page and show you the question. Now let's take a minute over here and tell me which of these is an additive manufacturing technique. A. Forming. B. Casting. C. Stereolithography. Or D. Milling. Come on, guys. Well, A is definitely not an additive manufacturing technique. And what I can see from the answers, you guys have got it correct. The answer is C, stereolithography, right? We'll just submit the answer and it is correct. So, stereolithography, also known as SL. Now, it is a technique used in both SLA and SLS. So SLA and SLS are two techniques of 3D printing like FDM, and stereolithography is the main, what you must say, a principle as to which SLA and SLS is done. So it is called SL in short form. Now let's get back. Okay, so moving on to our specific agenda for today, additive manufacturing. So what is additive manufacturing? Additive manufacturing, AM, is a process of joining materials to make objects from 3D model data, usually layer upon layer of material, whether plastic, metal, concrete, etc., as opposite to subtractive manufacturing methodologies. And this is what is called 3D printing. So here you can see a brief definition of additive manufacturing is there. And in the end, what we are, I've already explained it to you what is additive manufacturing. And it is the deposition of some material at the required place. It is a process of joining material to make objects from 3D model data, right? We create something of which we have a plan for. So 3D model data is our plan, usually layer upon layer of material, whether the material can differ. It can be plastic, it can be metal, it can be concrete. There are many more metals, so the material can differ, but the function of additive manufacturing will not. We are depositing material layer upon layer to make a final product, right? And this is what is called 3D printing. So this is a pictorial representation of how additive manufacturing is done. Now, as you can see over here, The first picture that I am highlighting, you can see a cursor that is going round and round. So the first picture over here is just the starting, right? The product is starting to print. You can see these layers over here, right? These layers over here, they are printing. So the horizontal lines that are there, the denser lines that are there, are the product, and the vertical line, this line you can see, these vertical lines that are there are the support. They are helping the product to stand up. Okay. So these denser lines, I'll repeat once again, these denser lines are the product, and the vertical lines are the material that is helping the product to stand up layer by layer. So at first, the first line was printed, then the second line was printed, then the third, then the fourth, and consecutively fifth, sixth, seventh, and eighth, right? So we move on to the next picture, the middle one. So here you see one by one the layers have increased. Now as you can see, the bed is moving downwards and the extruder is in its place and the bed is moving downwards. The extruder is moving right and left, and as this picture is in 2D, it may be going forward and backward also, but the upward and downward motion is being governed by the bed on which the printing is being done. Now, as you can see in the second picture, slowly the layers have denser layers have come closer and the part got joined in the middle. Still, the vertical lines are the support lines with the help of which the product is standing. Now, coming to the third picture, the product is finished, the printing is done. You can see an X, this is the product, and the vertical lines that you see are helping the product to stand up, so the product will not fall as the layers are being printed. This is basically the process of 3D printing. Now, here comes a quick quiz for you, and I shall go to the page where the quiz is happening. So this was the first question. We'll go on to the next question. Next question is, which part of the 3D printer is responsible to move the printer along the Z axis? Now the Z axis is the upward and downward axis. And come on guys, give me an answer. Think upon it and tell me which part of the 3D printer is responsible to move the printer along the Z axis. I repeat, this can be a trick question for you guys. So tell me, what is the answer? Okay, so most of you people are saying A. Someone said B. Well, you can be right. Yes. Then Dhruvi Gogna, right? Dhruvi Gogna said C, both the bed and the extruder. And no one of you is saying D. I guess yes. So Ishrit Tipdeval, the correct answer is D, either the bed or the extruder. Now, I will explain you this why either the bed or the extruder. So, the Z axis movement can be done by either the print bed or the extruder, right? In some printers, the print bed moves, or in some printers, the extruder moves and the print bed is constant. So here you can see the print bed or the extruder depending upon the type of 3D printer you use. So the correct answer over here is D. Either the bed or the extruder governs the Z-axis motion of the 3D printer. Well, in fact, basically one motion is governed by the print bed and two motions are always governed by the extruder, right? We'll go back to the PPT and So the scope of additive manufacturing. Now the scope of additive manufacturing, here we are. So production of models and prototypes during a product's development phase. So whenever there is a product that the company is launching in the market, there is quite quite of time and resources are spent on developing that product. So while developing that product, this is the best type of manufacturing method that is used. It is the most preferred one. Production of models, because additive manufacturing is piece by piece production. You cannot create hundreds of pieces in hundreds of products in one shot. uh, First the machine will create one product, then a second product, then a third product. It is not a mass manufacturing technique, it is a prototyping technique. It is basically there, it can be used to mass manufacture products, but basically it is a prototyping technique. So production of models and prototypes during a product development phase. AM technologies are used in the following fields: architecture, construction, industrial design, automotive, aerospace, dental and medical industries, biotech, human tissue replacement, fashion, footwear, jewelry, eyewear, education, food, and etc. So, as you can see over here, hardly there is any industry left that does not uses additive manufacturing technique in their work, right? So I'll explain it to you, explain all the industries to you in the upcoming slides. Let's move to the third point: short series production, where tooling costs for casting or injection molding would be too high. Now many of you must be automobile enthusiasts. So if I say, like, you want, or maybe any industry, if I say you want a specific product, but the quantity of that product that you require is just two or three pieces, right? You won't go for casting or injection molding, because creating a die for that is the cost for that die will be very, very high. So that is what the point of additive manufacturing is. No matter the quantity, the cost of the product will remain the same. You want to create one piece, the cost of the piece will be the same. You want to create 100 pieces, per piece of the cost will always remain the same. So that is what is called a short series production, where tooling costs for casting or injection molding would be too high. Now, coming to the fourth point: parts of high geometrical complexity which cannot be produced by means of conventional manufacturing, molding, grinding, milling, casting, etc. So, there are many types of designs that one cannot create with conventional manufacturing. There is molding, grinding, then there is lathe machine, and then there is billing, casting. But there are some designs that you cannot create with those conventional manufacturing techniques, and that is where additive manufacturing comes in, because it is very much capable of creating those high geometrically complex products. Now I shall give you some examples with the help of some pictures. Coming to this, the first picture that you see of a shoe. So yes, it is an Adidas shoe. You all would be knowing that brand. So the name of the shoe is Adidas Shoe 4D. It has a 3D printed midsole. So the first ever shoe company that used 3D printing technology in their products is Adidas. And as you can see, the sole of this shoe is completely 3D printed. The midsole is completely 3D printed. Now the second picture on the right, you can see it is a variable turbocharger. It is an extremely lightweight variable turbocharger by Koenigsegg. Now, Koenigsegg is a very reputed brand in the field of automobiles, and it creates, let's say, hypercars or supercars. But the quantity of production Koenigsegg does is very less. It does not create thousands of cars. It just creates, makes three or four pieces of that car, right? So, and to make a supercar, to achieve that super speed, the parts should be extremely light, and that is where Koenigsegg uh, did their R&D in this variable turbocharger. It is extremely lightweight, it is completely 3D printed, it is assembled, different parts are printed in different machines, and then it is assembled. Moving on to next. So aerospace applications. Aerospace applications offer huge potential for additive manufacturing. Now, as you can see on the right, on the top right, this is a fuel nozzle of GE's new LEAP passenger jet engines. Now, why? Also, there is a fun fact. Total 19 of these fuel nozzles are being used in one jet. So, as you can see, one jet uses 19 of these fuel engines, and there are hundreds of jets. So, why do they not create their nozzles with the help of conventional manufacturing technique, right? So, why are nozzles 3D printed and not made by a conventional manufacturing technique? So, conventional manufacturing technique does not allow us to optimize a product in terms of its physical properties, for example, weight and strength. Now, many of you would have a blind idea like if the weight is higher, the strength will be higher, right? So, that is a very conventional manufacturing technique, does not allow us to optimize a product regarding these kinds of properties, these related properties. Now, what additive manufacturing helped us in optimization of a part. So optimization of a part, you can see on the left hand side of this screen, a picture is there. So this is a bracket. It is a simple bracket. And as you can see, there are hexagon shapes. There are hexagon hollow shapes that are there inside these parts. So this is a hollow part. Now, many of you will say that a hollow structure is not very much durable, or does not have a good strength, right? Similarly, I will show you this picture. This picture in the right is a top. It is a top cone of a turbine. Now, if you can see inside the top cone of a turbine, there are hexagonal structures. It is a lattice structure of hexagon, and as you can see, it is hollow. Now, the same question arises here, like if it is hollow, how can there be equal amount of strength as compared to the solid part? Well, that is not true. Now, as you can see in the bottom of the screen, we have a transition. So what is the transition all about? This is a conventional part. It is a simple bracket. It is a conventional part. It is manufactured with the help of a conventional manufacturing technique. Now, similarly, the second picture over here, this one, it is a 3D printed part. Same design, same everything. It is not optimized. It is just a replication of the conventional manufacturing technique with the help of 3D printing. Now, third, we come to the optimized 3D printed part. Now, here you can see there are hollow spaces. There is lesser amount of material used. The outline structure is the same, and the holes wherever required for assembly, they are the same, but still a lesser amount of material is being used. Now, as you can see on the right hand side, bottom right hand side, there are two pictures that are blue and green colored. So what is this picture? This is a picture of an analysis report of the strength of this product. So as you can see, the solid part has the same and strength is represented with the help of stresses wherever the stress is induced in this product. So the colors denote the stress. Red is the highest amount of stress, blue is the lowest amount of stress, subsequently all the other colors as mentioned in the meter. So as you can see in the solid part, blue, there are not many stresses induced in the solid part, and similarly in the optimized part, a very low comparison is there, like it is highly similar to the solid part as to the stress induced in this part. So you can see, irrespective of removing this material, the strength is just the same. So what did we just do? We reduced the weight of the product. We reduce the weight of the product and the strength is just the same. So in an aeroplane, if you can see over here, if you can see an aeroplane or you can visualize it, you can just think about, if an aeroplane has to go in the air, it has to be light, and if we use heavy parts, its weight will it will reduce its passenger carrying capacity. So here, 3D printing this fuel nozzle helped uh, GE Aviation to increase its capacity and its flying speed. So moving on further, we've completed the optimization of a part. Let's move further. Now, as you can see on the top right hand side, this is a titanium alloy implant using laser metal sintering. Now, laser metal sintering is another type of 3D print. There are lots and lots of types of 3D printing, and it is a very vast topic. So, I'll just give you some examples. Titanium alloy implant. So, when now, as you can see, a person is putting some part of a skull in and fixing the skull. So during an accident, a skull is it was a very major accident and the skull is broken. So you can see the skull can be repaired. Now, why cannot we print this? We make this with a conventional manufacturing technique, because every person is different. Every person's bone structure is different, and the design of breakage, like if an accident is happening, something is breaking, and we have to fix it. Now, the repair won't be similar to each and every person. You understand me? So, this manufacturing technique is used for repairing that bone damage, right? Similarly, in the second picture, this is a 3D printed metal jaw. The jaw is obviously designed person to person. It cannot be same for everyone. So this jaw is printed for that person's bone structure, right? Now coming to 3D knee replacement implant. Similarly, nowadays elder people face issues while walking. So knee replacements are there, and these knee replacements are using the help of 3D printing technique to print specifically adjusted knee replacement implants for the person who's getting the treatment done. Next, additive manufacturing is making tissues using biomaterial, right? Additive manufacturing of tissues is being done using biomaterial. So a quick quiz is there. We move on to the next question. Which material is used for printing live organs? Well, there is a question, I guess. We'll take up questions at the end. So please stay tuned till the end. And very good, Divya, and correct answer. The answer is biomaterial. We mentioned it earlier also. So biomaterial are some type of, basically biomaterial is a category of material which are being used to print tissues, to print organs. Recently there has been research and people are trying to make a prototype of a working heart with the help of additive manufacturing. So moving on to the next slide. Now this might interest many people. So additive manufacturing is being widely used in the fashion industry, right? So you can see a dress is being made with the help of additive manufacturing, 3D printing. Now fashion designers, they design a dress and they want to look how is the design coming out in real life. They print it. Obviously the dress is not printed in one parts. It has been printed in different parts, and then it is assembled. But still they can feel what the outcome is of their design with the help of 3D printing. Similarly, there is a necklace over here that is 3D printed. Footwears are there, hats are there, then there is jewelry. Rings are being made with the help of additive manufacturing. People are printing silver directly to create a new type of design, because nobody likes a jewelry of the same kind with two different people. Nobody likes to share the same design with two different people. Everyone wants a different design. So that is where 3D printing comes in. Next, we move on to lifestyle products. Now, as you can see, our basic lifestyle necessity is a phone, and the necessity of a phone is a mobile cover. So you can see there are mobile covers are being printed. And me myself, I am using a 3D printed mobile cover, as you can see, right? And then there is this sunglass, or it is a spectacle. So you can see this spectacle is 3D printed. uh, the design of this spectacle, I like to mention this design. So this is the type of design that I was telling you about, what conventional manufacturing techniques cannot print, right? This web-like structure is not very easy to make with the help of conventional manufacturing techniques. Now coming to home decor. Now home decor is there. There are chairs, there are lamps. This is a stool, a flower vase, and there are many things that one can make with the help of 3D printing. Now, as you can see, we have covered the fashion industry, we have covered the medical industry, we have covered mechanical, automobiles, and aerospace. Then we have covered interior designing, chairs and flower vases, and many of these lamps are there. Now, secondly, we come to construction and architecture. Now, as you can see, these houses are also being 3D printed. Nobody want, irrespective of many people, nowadays, young generation wants a different house. Nobody wants a house similar to the next person they're living to. They want a different kind of house. They want a different architecture planning of that house. So construction companies are making those houses with the help of 3D printing, and they are well in use. India has started making these 3D printed houses, and that it is very much durable, and it is very much heat resistant also. Now, why is it heat resistant? That is a totally different topic, and we shall not get into that. Next, there is a quick poll for you. Can a pizza be 3D printed? Tell me, guys, can a pizza be 3D printed? Well, the answer you all are giving, it is very correct. Yes, a pizza can be 3D printed, and as you can see in this picture, on the left hand side, there are three nozzles, and basically what one nozzle is giving out the batter for the bread, the second one is pouring out ketchup, and the third one is pouring out cheese or mayonnaise, whatever it may be. But yes, pizza is being 3D printed according to your wishes, and the topping may be added manually later on, but yes, it is being printed, and maybe in future toppings can also be added with the help of 3D printing, right? Now, on the right, you can see a chocolate cake that is being made with the help of 3D printing. Layers and layers are being printed round and round, making different kind of structure, and on it is being placed on a bread over here. So you see, food industry is also being developed into with the help of 3D printing. Coming to categories of additive manufacturing. So categories of additive manufacturing, there are basically three categories of additive manufacturing: solidification of liquid, resolidification of solid, and precipitation of gaseous material. So a liquid can be solidified. How can you reach a solid? From liquid to solid, solid to solid, and gas to solid. So these are the three main categories. Now coming to fluid deposition modeling technology, this is the main type of main type of 3D printing technique that we actually use, that is generally in used. And FDM is an additive manufacturing technology that builds parts up layer by layer by heating and extruding thermoplastic filament. So here you see, as I'm showing you on my cursor, this is the thermoplastic filament, right? Then the filament goes up, the filament goes up to the nozzle. This black one is the nozzle. Then there is a 3D printed part, and then this is the bed, and the nozzle extrudes, it heats the material and extrudes the material according to the shape required, right? So ideal for building durable components with complex geometries, FDM is the only 3D printing process that uses thermoplastic materials, right? So what I would like to tell you over here is basically FDM is the only 3D printing technique that uses thermoplastic material sources. Example, PLA, ABS, nylon, etc. So any other technique does not use thermoplastic, and that is why it is one of the cheapest of 3D printing technology, and very, very unique, and not very unique, I would say, but yes, very important. So FDM can create parts and prototypes with good thermal and chemical resistance and strength to weight ratios. Now, as you can see, let's take up a quick question over here, and let's see if whatever I've told you, were you able to understand it, right? So the next question that is coming is, to which category of additive manufacturing does FDM belong? So yes, I can see answers over here. Right, right, very good. Yes, the answer, your all of your answers are correct. It is resolidification of solid. How can you deduce that? Because yes, the material is being reheated and deposited on a specific point. So the answer is correct. Now, quickly moving back to our. So the process, you can see the process of 3D printing. There is a CAD model that you design. Then there is the CAD model generates an STL file that is already in the, that is the part of designing, and your software will export your file to an STL file. Then comes the slicing software, layer slices and tool path. The slicing software creates the layer slices and tool path, and then the 3D printer follows that tool path and makes the 3D object. So data preparation for 3D printer. After the STL file is generated, it is sent to the printing machine software. Here it is processed, which includes part orientation. The part is oriented in such a manner that it can be built by the printer easily. Support generation. Initially, support are created by the software itself, but wherever the designer feels that the support should be added so that the object does not fall, he can add them. Wall thickness and part thickness. The thickness of the layer is to be defined properly in according to the desired strength and configuration. So as you can see here, I will explain all those 3 points in the software. And as you can see here, this is a slide stop. It is a part that I have made in a designing software, and then I have sliced it. Now, what is slicing? Slicing is the process of creating the tool path with the help of your slicer software. Now the tool path is created, and as you can see this red area, so I will explain this to you in this red part, the red wall surface, yellow one is the top wall surface, green is the boundary, and the light blue colored surface that you can see, the light blue colored surface that you can see over here is the support material. uh, I'll show you this, explain this to you in the software. So we'll go to the software now, and I'll just quickly give a brief about this. Is the this is Ultimaker Cura. Basically the name of this software is Cura, and it is made by the company Ultimaker. So here it is an open source software. This is the interface. As you can see, the square box you see in the middle is the print bed. It gives a representation of the print bed of your printer currently. So this is file basic. These are very basic options, and I'll just take a new file from the file menu and open this file. So this is the slide stock as I have shown you earlier in the PPT, right? So now as you can see, the size of this part that I have created is very big. So what will I do? I will scale it down, right? Now here you can see I scaled it down, and as I scaled it down, it is getting snapped to the print bed because it cannot be printed in the air, right? It needs to be attached to the ground. Now first thing is print orientation. Now as you can see, okay, first of all, the first column is the name of the printer. So I usually use a Creality Ender 3. Okay. The second is the material that I use. The third one is the nozzle that I use. And this is the settings. So settings will come to later. First, I'll show you the orientation. So on the left hand side, there is position, there is scaling, then there is rotation, there is mirror, there is meshing type, and then there is support blocker. Okay. So first of all, I'll position my object. I'll position it in the middle. Then I've scaled it. I've shown you how to scale it. In whichever direction I want to scale, I will scale it. Second of all, rotation, putting the product in the correct orientation. So my orientation would be like this. I suppose this will be best. Now why I think this will be best is because it is taking up the maximum space on the bed. The bed and the product adhesion is maximum. The surface area connected to the bed is maximum over here. So that is why I will select this type of orientation. Now I can use this one also. As you can see, I can use this one also, but this will have a lesser area of adhesion with the print bed, and it might disrupt my quality of printing. So I will use the maximum area of attachment, right? Now this is fine. I don't need to mirror it. I don't need to set the meshing type. I don't need the support over here. So I will straight away go to this setting. So here comes the quality setting of a product while 3D printing. Now I'll use this app for you guys so that you can clearly see what is happening. So here you see the layer height. Now each layer height is the amount, is the thickness of that layer. So here, if you use lesser layer height, it will give you higher strength, or vice versa, right? So here you see layer height is given, the height of each layer in mm, higher values produce faster prints in lower resolution. So the thicker the layer height, the lesser the resolution of your product, the less detailed it will be. Wall thickness is there. Wall line count. So how many lines of wall do you want? I want 3 walls of line, or you want 5 walls of line, whatever it can be. Let's say I take up 3. So my layer height is 0.1. Wall thickness is 1.2 because I want a thicker wall, right? So then there is top bottom thickness. So the thickness of the top part of the product, top surface, and the bottom surface. This is that thing. So top thickness 0.58, it automatically takes. Top layer 6 layers, bottom thickness 0.58, bottom layer 6. Coming to infill. Now, what is this infill? Now, as we have seen earlier, in the top part of the turbine, it was having a hexagonal structure. So this is what additive manufacturing helps in infill density. How much internally filled should your part be? It can be 50% filled, it can be 80% filled, it can be 60% filled. So let's suppose I take 60%. Infill pattern is there. There are number of patterns that you can use them. While you use them, you can check which of the pattern is which, because it will be very difficult for me to explain it over here. Then there is printing temperature. Printing temperature is totally governed by the printing material. Build plate temperature is totally governed by the material and the temperature available in your printer. Printing speed is up to you. So higher the speed, the lesser the resolution or the detailing of the product. So I would suggest not very high speed. Let's keep it to 100 millimeters per second. Enable retraction and Z-hop, that is not. Now enable print cooling. So if I enable print cooling, what will be my result? If I do not enable print cooling, what will be my result? So this is a question I leave on to you guys, and you shall think, and I will give you the answer later on. So next thing we come to support. So generating support. Now, as you can see, this generate support, I have ticked on generate support. So it will create support, and the overhang angle is there. Overhang angle is after what angle the support we require support. So I require support after 45 degree of angle. Okay. So now I will just slice it. Now, as you can see, it is being sliced. So while I go to this slice, I will go to the preview. So there are three options: prepare, preview, and monitor. Monitor I cannot access right now because I am not connected to my printer. So I will go to preview. So you can see the preview over here. So here you see red wall is the product, yellow, as I said, top surface, green is the wall. Now the blue part that is created, this light blue part over here, is what is called the support. Now, why is this support created over here? Because this support is exactly 90 degree from the vertical. So I have put the entry as 45 degrees. So anything beyond 45 degree will get a support generated, right? So how will it get printed, right? That is the question. So you can see layer by layer it is getting printed. At first, this will be the layer. Now, how will it get printed? Let's say this layer is getting printed, and we'll zoom on to that, and I'll just and play. So you see, this is how it is getting printed. The nozzle is depositing material one by one to each and every pace, and here it gets printed. So this layer is complete. Now similarly there will be around how much? There will be 583 layers, and the product will be completed. So this is a short brief about the printing software, and we shall go back to our presentation. Now, the question I asked you earlier: cooling is necessary to ensure the print quality, yes or no? Cooling is necessary to ensure the print quality, true or false? Well, yes, true. That is very true. Cooling is necessary to ensure print quality. Now, that was what my question was earlier. Because cooling, whenever I enable cooling, it will bring down the temperature of my melting material from 200 degrees back to the temperature, bed temperature that I specified. So the warping of my material, warping is another term when the material contracts irrespective of the location, it contracts on its own and it disrupts the print. That is what is called warping. So cooling will reduce the amount of warping, and hence it will create a higher quality print. And this is a picture of what I would say. I recently created this product for a company, and this is a lock of a machine. This is a lock of a machine. So the lock was previously metal based and it broke. The lock was not easily available in the market. So this company came to me and I had to redesign it, uh, change some specifications according to the material. So I created this part with the help of plastic. This is PLA. So I created this part with the help of PLA, and the product, that original lock, was of metal. So as you can see, you can also replace plastic parts with, you can also replace metal parts with the help of plastic parts. And that is where the webinar comes to an end. And thank you very everyone for being patient, and I hope you all liked it. And over to you, Manpreet. That is it from my side.
Definitely, Manas. We all had a great time, I'm sure. I personally enjoyed the session a lot. And now I think we can open the floor to our audience for some questions. But before we go there, I have a question for you on behalf of everyone here. So, my question to you is that as somebody who is eagerly interested in learning more in this field, what is the right path for me?
As someone, if someone who wants to begin in this field, I would really suggest to actually know on what they want to use it for. And when they are really clear on their mind, like what they want to use it for, I guess Internshala has a very beautiful training, and it has a lot of practice tests and assignments, which would actually give a very brief knowledge, a very not brief, but I would say a very good amount, ample amount of knowledge to explore yourself in this field. And that is what it is all about. Additive manufacturing is not very well established, if you say, but it is a field that should be explored at the highest level. And I really recommend this training because it has a good amount of assignments and really good descriptions of the technique.
That's right. Internship Trainings is live with the Grand Summer sale right now. We are offering a special 80% discount on the 3D printing training along with 70 plus other practical based online trainings. The sale is live only till tomorrow midnight. So, what are you waiting for? Just click on the link in the description and go and grab your training. Now we can open the floor to our audience. So, Manas, if you could please take up a couple of questions from them.
Yeah, sure. So everyone, please write down your question if there is any, and I shall be happy to answer them. Uh, Arun Singh Panwar. So the question is, kindly let us know your recommendation for an affordable 3D printer. So there are many good 3D printers there in the market. You can look it up online. But what would I suggest that Ender 3 is one of the printers that that was my first printer that I used. So I would recommend it. It is an affordable one, so you can go for that. Uh, so yes, does the next question I would take up is, does the printer also print the supports? Yes, the printer also will print the supports. Now, coming to that, I would just explain it a bit. The part is dense. The part will have a denser amount of material, but wherever the support will be printed, it will be lesser dense. So it will be easier to break it off. It will be easier to remove it from the main print, right? Yes, exactly. So the question is that is what I explained. How do we separate supports from final model? You will just have to peel it off. The support is not that much well attached to your main part. It is just holding on to by a thread. So when you pull it out carefully, it will get removed. Okay, okay. I missed one question on top. So, what is a wall line and top in the slicing software? Uh, so, Akshay, what I would suggest you is wall line and top. Wall line is the line that is there on the wall. You can see a 3D print. Now, if we set the infill density of a product to 50%, so the inside will be weak, right? Inside will have, it will not be exactly weak, but it will have lesser amount of material. But we don't want our walls to be less thicker. We want our walls to be thicker. So that is what is wall line and top. So wall line is the line that is there on the wall, and the top surface, as you I'll just show it to you. If you can see over here, so the green line that you see, this green line over here is the wall line, and the yellow surface over here that you see is the top, right? So this is what is green line, this is wall line and top. So we want the wall lines to be very much durable, and also the top to be durable, because that is the surface, and surface will definitely come in contact with some other part when it is, when the product is used, right? Either it will be in contact with the environment, or it will be in contact with some other part. So we want the surface and the walls to be of a durable nature. So they should have strength. So that is where the wall line and the top comes in separately. It is not a
Okay.
different part of the product, but it is there.
Thanks, Manas, for that answer, and thank you for the amazing webinar. And thanks everyone for joining. Don't forget to like this video and share it with your friends. Do subscribe to our YouTube channel and press the bell icon to never miss another update regarding any video or upcoming events that we have. You can also join our Telegram channel and get updates regarding our events from there. The link is in the video's description. And see you guys next time. Take care. Thanks, Manas, again. Bye, everyone.
Thank you. Thank you, everyone.